Rega is a Swiss air rescue. They aid people in distress providing swift professional medical assistance by air. In order to do so, they need to be experts in inventory management. Imagine the terrible consequence they would face if they ran out of an important medical product. We contacted the head of logistics and procurement of the Riga headquarters in Zurich to get some insights about the challenges he faces on a daily basis. One of them is to correctly identify the optimal order quantity of the different products. Based on real data, we're going to show you one technique to determine the optimal order quantity of infusion bags in an easy and straightforward way, using the economic order quantity model. Let's first have a look at what the economic order quantity model is. The economic order quantity model addresses the optimal order volume of a product based on a total inventory cost. In other words, how many items shall a company order each time related to how much inventory the company shall keep on hand and how often it wants to place orders. The model is based on 7 assumptions. Annual demand is known and constant. The cost of order is constant. The whole order is delivered in one batch and at the same time. No stock out possible. No lead time. The cost of holding is linear and per unit. And last of all, cost per unit is constant. Total inventory cost consists of ordering cost plus holding cost. These costs counterbalance each other. This means that purchasing higher volumes less often would decrease ordering cost, but doing so increases holding cost, since the average level of stock kept on hand is higher. The ordering costs are determined by the cost per order, CO, times the total number of orders, here presented as demand divided by the chosen order quantity Q. The holding costs are determined by the holding costs per unit per year CH times the average level of stock, described as Q divided by 2. One goal of an inventory manager is to minimize the sum of these two costs. Let's now have a look at some real-life examples of ordering and holding costs. Ordering costs can consist of processing and sending the order, processing and inspecting the incoming inventory, inbound logistics, other administrative costs, salaries and wages of purchasing department employees, etc. Holding costs, on the other hand, consist of salaries and wages for warehouse employees, utility costs for the warehouse, insurance of the products, building or renting costs for the warehouse, obsolescence, etc. Minimizing the sum of the two costs explained before leads us to the optimal order quantity formula. Q equals square root of the product of 2 times annual demand times cost per order divided by the holding costs per unit per year. In our case, we are going to use the EOQ model to find out the optimal order quantity of infusion bags the inventory manager of the Rega has to order to minimize his inventory costs. Firstly, we have to identify the costs per order. In our case, this is an administrative expenditure of 200 Swiss francs per order placed. The next variable we have to determine is the holding cost. This is 168 Swiss francs per unit per year. The holding costs of infusion bags are quite high compared to their price. This is due to the fact that they are heavy, must be held at a specific temperature and are also fragile, so they can't be stacked on one another. Before applying the exact formula we explained beforehand, let's do a simulation to show what effect different order quantities have on the inventory costs, to show which alternative is the closest to the optimum. On the upper left part, we can again see the data we have received from Rega. We will run the simulation taking into account 44 possible order quantities, from 50 to 2,174, our annual demand in steps of 50. These are shown here under alternative order quantities. The total number of orders can be easily calculated by dividing our annual demand by the order quantity. Then the total order costs are calculated by multiplying the total number of orders with the order cost of 200 Swiss francs, whereas the total holding costs are calculated by multiplying the average inventory with the holding cost per unit per year of 168 Swiss francs. In order to gain a better overview, we can use conditional formatting and include data bars. This enables us to clearly see how order costs decrease with a higher order quantity, whereas the opposite happens with holding cost. They increase with a higher order quantity. Finally, we can calculate the total inventory cost by adding up the total ordering cost and the total holding cost. Here too, we can gain a better overview by using conditional formatting and include the color scale. We can clearly see how total inventory costs are higher at the extremes of the order quantities and lower in the middle of them. Another tool that we can use to better visualize the simulation is with the help of a chart. Here on the x-axis we have the different order quantities, while on the y-axis we can see the costs in francs. The total inventory cost can be found at the intersection between the total order costs and the total holding cost, here somewhere around 700 units. By doing this, however, we have only derived an approximation of the optimal order quantity, that is around 700 and 750 units per order. Companies are often interested in a more precise figure. This can be calculated using the famous formula we derived previously. Square root of 2 times annual demand times order cost divided by holding cost. The same result can be obtained using some Excel magic. For this, we are applying the solver function. Firstly, we set a random number of order quantity and calculate the inventory cost, summing up the total order and holding cost. We do now make use of the solver function. Here we set the inventory cost as objective, which has to be minimized. As a next step, we need to define the changing variable cell, which is in our case the order quantity. Finally, we click on the Solve button. As we can see, this again gives us a result of 719 units as the optimal order quantity based on the data above. Thank you for watching. We hope you enjoyed the video.